So it is the second term in technology. We've already gone through these first few pages already and underlined a few things. So I'll just go through it again so you guys can see what we have to underline, what you must study. You guys can pause the video, rewind the video, watch it over and over again so you guys can get all the information. But we're now on page 2. For those who don't have the handbook, we're looking at what is a frame structure. So here the definition of a frame structure is: a frame structure, see figure 1.1 right over here, is an open structure that is not like a solid structure. So you'll see over here, if you look at figure 1, there is a bunch of metal, which makes this frame structure, and inside the metal there's open gaps. Now that's why they say it's not like a solid. So if you see figure 1.2 over here, you'll see it's a solid piece of metal. It's a solid piece of metal which forms an I-beam, but this one over here has gaps in it. So here, now if you see figure 1.2, a frame structure is made up of a number of parts that are called members. So you see there's different parts, different pieces of metal put together to form this entire frame structure, and those are called members. And some frame structures are also called trusses. So this thing can be called, the whole thing can be called a truss. So now if you go skip this task, enabling task, go down to your roof trusses. It says a roof truss is the frame structures that support the roofs of houses and other buildings are called the roof trusses. So you'll see here, there's activity here where it asks you what is the function of a roof truss. And all you need now is say a roof truss is the frame structure which supports the roof of houses and other buildings. Now a roof truss can be made of wood or steel. Now here in figure 1.3 shows an example of a roof truss. Right over here, some men building the roof of a house made of wood. And right over here, there are various designs for roof trusses. And here's 4 designs right over here. It doesn't matter which design it is, they all serve the exact same function. Now here on the next page, page 3, the members of a roof truss. Now this is very important. You'll see I drew on this thing a little bit and I highlighted all the words. But this right over here is didn't pen. This right over here is NB. NB, very important. It's basically explaining what each of these parts of the roof truss is. So here at the top, figure 1.5 shows the different parts of the most commonly used design for a roof truss. Now this design over here for the roof truss, with the king posts over here and the queen post, the rafters over here, this is the most common design for a roof truss. You'll see if you go to your house, if you climb into your roof, you'll see it's most probably this roof right over here. And this is what most of the houses' roofs look like. Unless you have someone who wants a specific house, then they will go and make a specific roof truss design. Now the distance between the walls of a building right over here, here's the wall, and here's the wall over here. The distance between the wall of the building that support the trusses is called the span. Right over here, here's the span. So the span is this distance right over here at the bottom. The members of this roof truss are not all the same. So the distance of this over here, of the roof truss, and the height and everything, all of them are different. They are all different members and they all have different functions and they all have different lengths. As the diagram shows, the different members are in the different positions on the frame and their lengths are not the same, like I just said. The lengths differ and the position differs and the function also differs. So just a little bit down over here. Each member of the roof truss has a different function in helping to support the roof. Like I said earlier as well, each different part has their own goal, has their own achievement which they are trying to do, and they all have different purposes. So now here is a little bullet point list which shows each of these parts and their function. Now the rafters are right over here on the side. So these ones going on the slope is the rafter. It shows it right over here, but I don't know if you can see it now because I underlined it. The rafter right over here. The rafter are sturdy members on which the roof is fixed to the truss. So the rafter is used just to attach the roof plate. So here you have a roof plate over here, and you want to attach this roof plate to the rafter using nails or bolts or whatever. So that is what your rafter is for. It's just to attach the roof. Now the king post, right over here in the middle. This is the king post. It's also labeled over here, king post. The king post supports the top end of the rafters, right over here. This top end right over here. It supports them over there. And the angle of the roof to the horizontal is the pitch of the roof. So you see this 30-degree angle over here is the pitch. So pitch means the angle of the roof. And this is also known, so you see over here, I said pitch over there, but this angle, if you read over here, it's usually about 30 degrees and is known as the pitch. So now, the queen posts. The queen posts are basically the same as the king post, but they're just a little smaller, and they're on the right and on the left of the king post. So, the queen posts are used on trusses on buildings with a long span to support the rafters. So, if your rafter is short enough, then you won't have queen posts. But if your rafter is too long, then they will have queen posts in the middle between the king post and your wall, just so that your rafters are more supported, and that is their function. Now tie beams, it isn't labeled on the drawing, but the span right over here is your tie beam. The tie beams are used to fasten the bottom end of the rafters on one side of the roof to the rafters on the other side, so that the roof does not collapse. So now, the tie beam is this piece of wood going all the way right through here, up until the end of the wall. And it's used to attach the rafter to the tie beam to the wall. Because if this wasn't here, then your rafter would just slip down. But now your rafter is attached to your tie beam, and the tie beam is attached to the wall. They also support the king and the queen post. So you'll see over here, here's the queen post at the bottom, and here's a king post at the bottom, queen post at the bottom. So the king post and the two queen posts are attached to the tie beam for extra support. And now the wall plates. The wall plates are right over here above the wall, and you'll see every single wall has it. Now the wall plates are on which the tie beams rest, and placed along the top of the walls. So the tie beams aren't attached directly onto the wall. The tie beams are attached to the wall plate, and the wall plate rests on the wall. So that is the whole roof truss and all of the members and their functions. So this right over here is very, very important, because you will get this in a test. So here is a enabling task 1.2. It's just 2 questions. It says, the first one says, what is the function of a roof truss? Now, like we said earlier, it's right over here. The roof truss is a frame structure that supports the roofs of houses and other buildings. There we go. There's the answer, 100% finished. And now for the second question, I drew a little sketch here earlier. I drew on now a little bit, so please bear with me. So here is a sketch which they are referring to. They ask you, if the height of the king post, so right over here, here's the king post, there's the king post over there. If the height of the king post of a roof truss is increased, so right over here, here's the original one. Now the king post is increased in height, but the span is not increased. So here's the span, the bottom part, where the tie beam is. The span stays the same, but the king post rises. Which is the only part of the truss that will not, emphasis on will not increase in length. So since this king post gets increased in length, obviously the answer is in a king post. And when the king post increases, the angle increases, and that makes the rafters increase as well. And since the rafters increase, the queen posts increase as well. And when this distance and this distance grow further apart, then this distance also gets increased. So the only part of your roof truss which does not increase is your span. And like I said earlier, the span is also known as the tie beam. So the answer is the part which will not increase in length is the tie beam. And there you go. It's just 2 little questions, very easy. And that is it for the roof trusses. So now moving on to forces. Right over at the bottom of the page, page 3. Forces that can be exerted on members of structures. When a force is exerted on a member of a structure, it acts on the member. There are 4 different forces that can act on the members of structures, and it's right over here. There's a tension force, a compression force, a shear force, and a torsion force. Only those 4 forces. So now here's the first one, the tension force. A tension force is also called a tensile force. And you see I underlined this because it's a different word. So if I use the word tensile force in the test, then you must know that it's a tension force. So now here's the second sentence. This force pulls on a member by stretching it. You see I underline this part of here where it says pulled and stretching it. So if you in a test refer to pulling or stretching, then you will get the mark, and that's why I underlined it. So pulling or stretching, and then you will get your marks for it. So here in figure 1.6, a member that is in tension is called a tie. This is very important. Actually, I didn't underline it yet. So if a member is in tension, it's called a tie. That is very important. You will do it in one of the activities on the next pages. A tie. It's just something you must know. So here is the example in figure 1.6. Here's some weight over here. It's a load, and it's pulling down on this rope, and it's making tension in this rope over here, all the way going up until there, in both directions. So it's pulling it that way, and pulling it down. So it's pulling everywhere. So that's why it's a tension force. It is a tension force, which is also a tie. Now on the next page, page 4, is the next force, a compression force. Now a compression force is the opposite of a tension force. So if you can put 2 and 2 together, you'll see that a tension was pulling, so a compression is pushing. So you see right over here, a compression force is also called a compressive force. You can underline that over there as well. Compressive, compression. So if you use any of those 2 words, it'll be right. If I use any of those 2 words, then you must know which one it is. Now see, like I already said, this force presses on a member by squashing it. So if you use the word push or press or squash, you will get your marks. That's why I underline those 2 words. Now here you'll see in figure 1.7, a member that is in a compression is also called a strut. So just like here in the previous page, where a tension force was called a tie, this is something you must know. A tension force is a tie, and a compression force is a strut. So here in figure 1.7, you'll see here is some weight of a wall or a building. Now this weight is pressing down on the pillar, and this ground acts as resistance, which also presses up to the pillar. So you have this squashing onto the pillar. And so because it squashes, it's pressing it, it's pushing it. It is a compression force. So here's a shear force now. The next one is the third one. A shear force. A shear force tends to cut a member. For example, scissors exert a shear force on the material they cut. Opposite forces act at the same place on the material. So what they mean by this last sentence, opposite forces act at the same place on the material. You'll see in this example over here, figure 1.8. Here there is a pin in between 2 pieces of metal. And there's a force which pulls up, and there's a force which pulls down at the exact same point. So that is called the shear force. And if this pin isn't strong enough, then the shear force will break the pin, and then that will cause very big problems. Especially if you have a shear force in buildings or in anything big where people's lives are at risk. So here's the last one, a torsion force. This one's very easy. If you want to remember this easier, this torsion, just think of your torso, think of your abs, think of your abdominal muscles, and your abdominal muscles are used to twist. So here it is, a torsion force tends to twist a member, just like your abs. If you stand still in one place and you twist from one side to the other, that is a torsion force. And here's in figure 1.9 and 1.10, there's a piece of metal which is being turned in a circle, or a screwdriver. Now we're going to just leave this how-to out. We're going to go to page 5. Here's a little example where they give you this diagram over here, this figure 1.11, a simple structure that supports a load. So here's the load, here's X and W. Now they ask you which force is used in X and W. So since this weight is pulling over here, it's pulling X this way, you should know that a pulling force is a tension force. And also because of gravity, this wants to swing this way. The weight wants to swing downwards to your right. And since it's pushing this way, it's pushing on W. And a pushing force is also a compression force. So this is what will happen if the tension force of the weight is too strong, then X will break. And this is what will happen if the compression force is too strong, then W will break. So it's just showing you what will happen if the forces are too strong. Now here's an enabling task. I just want to cover this up for 5 seconds unless you've already seen it. So it's just a little quick task. It just asks you, let's just cover this up quickly with something. With my beautiful bank card. So here it says in this task over here, do this activity on your own, draw a table in your workbook like the one on the right and record your results for the questions. So here it says, here is your table. Here it shows the members number 1 to number 6. This is question 1, tensile or compressive. Question 2, strut or a tie. And you'll see all you must do now is this is very easy. The first question is the force tensile or compressive in each numbered member in the 3 framed structures? So all you would do now is you look at number 1 right over here. Here's number 1. Now you see, is number 1 a pulling force or a pushing force? You'll see that figure 1.14 is the exact same as figure 1.11, just turned sideways. So 1 should then be a tension force, which is a pulling force, and you'll see right over there, I wrote pull. And like you read in the previous page, a tension is called a tie. Now in question 2, it asks you is it a strut or a tie, and since it's a pull force, you make it a tie. Out of here, strut equals push, and tie equals pull. So now you would do the exact same with all of them, and you can just put 2 and 2 together. If 1 is a pull, then 2 will automatically be a push. So since 2 is a push, it is compressive, and a compressive is a strut. Now it goes on to 3. Now this weight over here is pulling down on this rope, so it's causing tension in between the rope right over here. And since there's tension, it is a pull force. A pull force is a tie. And since this rope is being pulled tight, it wants to force this joint this way. So it's pushing this joint this way. So that makes 4 a compressive force. That's why it's push, and that's why it's strut. And the same goes for this last figure here. Sorry, this can be a little confusing, but you must just, it's very simple. Look at this. These 2 are being pulled down. This one's being pulled down, pull, pull. All of these are pull forces right over here. So that means number 5 is a pull because there's weight hanging and it's pulling that downwards. So 5 is a tension force, and since this is being pulled down, just like in figure 1.15, it's busy pushing. Since there's a corner, it wants to push the corner so it makes a straight line. So here it's bent and it's pushing it inwards so that it can make a straight line. And that's why 6 is a compressive force, that's why it's push, that's why it's a strut. So there's the answers to it. You can pause the video and put the answer down if you understand. We're now on the next page. This is unit 2. This is also the unit where we stopped as well. So over here, it just gives you a bunch of information based on these pictures and some stuff which you did in grade 7. It doesn't matter. And here it just shows you a little task which you must do, which we aren't going to do, so you can leave that out. And there's a little bit of information over here is based on the previous page, based on a torsion force. So here when you have electrical pylons, they are just squares. So you want to make made them stronger. And people have thought of the way by putting in a brace. Right over here is called a brace. You put in a brace to strengthen this tower or this shape to make it stronger. Because I don't know if you knew this, a triangle is the strongest shape there is, specifically the equilateral triangle. So if this is 60 degrees, 60 degrees, 60 degrees, this is the strongest shape there is. There's nothing stronger than an equilateral triangle. So that's why people put a brace inside. So you'll see that over here in the second sentence, this member is called a brace. It's when the member that was added diagonally. So when this member was added at an angle over here, this is an angle over there, it's added diagonally, and that now is called a brace. It forms two triangles, which, like we just said, is the strongest shape there is. Two triangles and two braces, trusses in the same way is called triangulation. So as soon as you put a brace in between a rectangular shape or a square shape, then you are triangulating it, which makes it stronger. Only trusses that are made up of triangles are rigid. That's why you see over here in the drawing over here, there's triangles everywhere. No other geometric shapes can be used to form rigid trusses, which we have already said. That's why also on the previous page, that's why we have these, the queen post and the king post and the rafters, so we can make everything triangles. Then it makes it stronger. This is why all electrical pylons are triangulated frame structures. Like I just said, they're all triangulated. So pylons must also resist torsion force right over here. Like I said earlier, torsion force caused by the wind. The wind causes electrical pylons or any tower to experience a torsion force. This resistance is provided by fitting members across the inside of the pylons. Just like the brace, they just put braces inside of the pylons. And right over here, these members are called cross-bracing members. So just, if there's just one brace, it's called a brace, just a normal brace. But as soon as you have two or more braces, which cross each other like an X, then that is called cross-bracing. Then it's no longer called a brace. And this increases the strength of the whole structure, makes it a triangle, and the triangle is the strongest shape there is. That is all which we've done in the second term so far. Next, we're going to carry on with Unit 3. We're going to be finishing Unit 4 over here next week. And then we will be doing this revision activity, which is just a few questions. That is all which we have done so far for Technology Grade 8E.